Nope. We're not doing that this week. We're doing this. We're at the Birmingham NEC for MACH 2024. The MACH exhibition is the biggest exhibition of its kind in the UK and is full of all sorts of machinery and technology. There's a massive range of manufacturing machines, measuring equipment, robotics, additive manufacturing, cutting, welding, the list goes on and on. I was fortunate enough to have some time off work, only 2 days though. I wish I could have spent the whole week here. But it's such a big exhibit I didn't get to see everything, so I've only included some parts of what I did see and I'll try and explain some things throughout the video. I was also lucky enough to have the chance to interview a UK based company to ask them some questions about CNC machining, which will be later in the video. I was surprised to see this stand. I thought Citizen just made watches, but it turns out they make some of the most precise CNC machines in the world, which is no surprise. This was fun to watch. This robot is automatically loading and unloading parts in this CNC lathe. It tells the CNC machine when it can release the part and when it can clamp the new part to be machined, all in one smooth operation. It then places the completed part and picks another one ready to go. Another robot loading parts, this time into a Mitutoyo round tracer, which checks the various diameters of the part to ensure it's within specification.
This is measuring the run out on the tooling, but it's also taking a photograph of each edge.
This is for you to measure how much wear a part you're machining is causing on your tool.
The repeatability of the whole tool and adapter is 2 microns. The higher up in the range you go, you then tend to get sub-micron.
I definitely need one of these robotic welders for the Metro. I love seeing 5-axis CNC machines in action, and this didn't disappoint. This is a UK based company called OnDrive, and they make off-the-shelf and bespoke gearboxes and transmissions parts. I'll put a link to them in the description if you need anything. Yes, that's a turbo impeller. This is a miniature Darth Vader helmet being cut on a 5-axis CNC. This was one of the most impressive things I saw, and this is in real time. This is a 4 meter by about 2.5 meter wide bed. You can see how fast this thing is moving around. It's a fiber laser cutter, and this cut is in real time. I was very impressed. But these machines are around £65,000 plus VAT, so I don't think I'll be buying one anytime soon. This thing was absolutely incredible, and yes, that says 21 million lines of G-code. I know at least one of you will recognise what engine this is. It's a 3.9 litre Rover V8, but you already knew that. I would have loved to have had a go on this, but I just didn't get round to it. Anyway, now it's time for the interview section. Forgive the slightly shaky camera work here. Some of the stands had free beer on tap and my fiancée took full advantage of that, so the semi-drunken shakes are her fault. I'd like to thank MACH Machine Tools, especially John and Sam, for taking time out of their day to answer some questions. It was the end of the day and I'm sure they would have preferred to be drinking a beer rather than talking to me, so thanks again to them. This is the first interview I've ever done on camera, so feel free to rate me in the comments from 1 to terrible. Okay, so we're here with John and Sam, and they're from MACH Machine Tools, and they're going to tell us a bit about the machines, what they do, how they work.
Machine tool like this is a CNC machine. We can operate it by manual operation using the jog panel. So we can go to jog. You can see us move the machine with the jog buttons, right, like that. Or we can engage the MPG. So this is where we call that an MPG because it's a manual pulse generator. All it is sending pulses, and you select the axis and the distance of each pulse. So in this case, I'll choose x-axis and 100. So that will move the machine manually and even down to 1 micron increments, like that. So you can control the machine very fine and precise manner using the handheld MPG. Next step, spindle. So you can just type in an RPM, let's say 3000, hit spindle run, and it'll rotate the spindle. So it's as easy as that. That's the jog screen in jog mode. Then we can use the offset screen to call a tool out. Let's call tool 8, which is our probe. And this particular tool changer is what we call a spider. It's unique to us because it looks like a spider when the arms come out underneath.
Yeah.
And it's got 8 tools as well. So certain machines like this has an automatic tool changer because it's gonna afford you to run this machine in a more automated, unattended manner.
Right.
You can program your part using many tools and just come back when it's done. It'll automatically run through all the tools and do the machining. We do have what we call a conversational editor on this control. That means you can program this control very easily. And in our case, we can open up a DXF drawing, set my 0, and that 0 will correspond to how I put my part into the machine to set the 0 to. So then when I program this part, it will run it at exactly that place on the machine.
So the machine knows exactly where that is.
Right.
Every time you swap the part out, it's always in the same place.
Right, so that's why I set my 0 on the drawing before I imported the features. And then I can just import, let's just say for example, one feature, a contour. So I selected that, then I'm gonna choose the contour event, and you just go through the event parameters. Here we have tool, start depth, end depth, incremental depth, and other stuff like side passes, finish pass, allowance, and then feeds and speeds. So with that all set, I'll hit save, and I can preview my path.
And that's showing you how the tool is going to come down.
Correct.
And
That's
go around
showing,
to make the shape you want to make.
Exactly. So then, if I were to save this program, it's going to generate the machine readable code, and that's my actual machining program. So from there, if I've got my part and my tools set up, I can go to auto and hit cycle start to run the program. So that's basically all there is to this CNC machine.
So what's the situation with repeatability with a CNC machine? Is that one of the main reasons someone would go for a CNC machine? Or is it more the efficiency and the speed of how it can operate and how quickly it can?
It's absolutely all about the repeatability because manually you can't physically get to the same place as well as a CNC machine, which are servo driven. And in our case, it's going to be a CNC numerically controlled plus a servo driven mechanical link. And in our case, it's digital. The encoder feedback on this will be close to 1 million pulses per revolution.
Okay.
So you can afford very fine increments, micron level. And certain machines like this, we have an absolute encoder. So when you power on the machine, it does not require homing. It knows where it is at all times.
If you switched it off
Right.
mid-cycle, or you had a power cut or something,
Right.
you switch it back on, it knows where it is, and you can just home it to get it out of the way. So the microphone didn't pick Sam's voice up very clearly here, so I've boosted the audio as much as I can.
You can retrace to the exact same line in the program.
Right.
If you wanted to. So
Okay.
You could have a full-blown power cut.
Yeah.
And assume it's all in fine. Assume exactly where you stop.
And you talk about repeatability. There's a figure on all these machines. They call it repeatability and accuracy. And so these are in the range of 3 to 6 micron, somewhere around there.
Accuracy and then repeatability is less or about the same?
I think one figure is double the other.
Yeah. Right. Typically, your accuracy is always bigger. You think about it like throwing darts at a dartboard. How close to the bullseye can you get?
Yeah.
So in any given position in this 3D volume, how accurately can we get to that exact point? And then your accuracy will be your variability. So you may not hit that. You may be a couple of microns from that point, 1 or 2. Now, the ability for the machine to move back to the same position is your repeatability. And typically, it's lower. Because the machine will be able to move back to the same position as it did the first time.
In certain machines, like enclosed BMCs like this, we would run a laser compensation tool and then have that compensate for the ball screw. So sometimes
So any backlash in a ball screw would be
correct
compensated for.
together,
Right, okay.
and there will be a table on the control where it says how far from machine 0 should I comp, and it looks like this with a return that accounts for both the backlash and the ball screw lead screw error. And the machine, the CNC would know how much error to apply at every location.
Okay.
So that gives
impressive.
you even higher level of accuracy.
Got a couple of questions from some followers. First one would be, what can a CNC be used for? And I've seen you guys do CNC lathes, you do CNC milling machines. You can add also to this a 4-axis, which you've got in this machine. Yep. So you can turn on this as well as mill. Yeah. What range of materials can you be worked on for removal or modification? Is that more down to tooling rather than the machine, or does the machine have an effect on it as well?
The range of materials that you can machine is determined by the tooling, but you will run up against some materials where the machine will become the limiting factor.
Right. So the spindle power is
there
hold
may
you
be
back,
some
say, cutting Monel or Inconel or something like that.
Exactly. So yes, is tooling, but in the same breath, yes, your machine capability does come into play there.
Right.
Also, when you get into materials, certain composites, you will require a certain level of extraction from your machine.
Right.
So there's other factors that start coming into play. It's not just how we cut it. How do I remove it? How do I deal with the swarf? So there's it's a multifaceted question, but typically we can cut almost anything.
Right. Okay.
It's really 3 components. The machine, actually 4 components. The machine, the tool, the program, and how you do the feeds and speeds. Just gotta make it play nice.
Yeah. Yeah. So with regards to the tooling itself, obviously for someone who's, say, a hobbyist just starting out, they've just bought their first, maybe a second-hand CNC machine, is it worth spending the money on carbide tooling, or are they better off sticking with high-speed steel if they're just machining basic aluminium mild steel? Or are they better off going for carbide straight off the bat so that they've got the longevity?
It's a tricky one to answer. I would say it depends on your personal level of experience. I would say if you're a guy just starting off, you're just learning the ropes, just getting a new machine, maybe you don't go overboard with the tooling. Optimize your programming, optimize your use of the machine, and then when you hit the limit of your tooling, then start to think about upgrading maybe to some carbide.
Right.
Because you can dive in and spend as much as you want on tooling. Some of these tooling guys are gonna sell you very fancy solutions to what could be a simple problem.
Yeah.
So I would say go to the lower end tooling, learn as much as you can, and then when you feel you hit the limits of that tooling, then start to do your
Put
research.
a bit more, invest a bit more in your tooling. The next question we've got is, what are the pros and cons, financially and time-wise, for small-scale use versus mass production?
You got to really look at what type of cycle times you want, and then decide if you're in a position to choose what type of machine. You really need to just know how many parts I'm making, how fast do I want to make it, how efficient I want to to be on tooling, and then the rest are simple, like
Yeah.
programming. You can reprogram that based off of it. In terms of machine tool wise, certain machines do production better. Certain machine tools do tool room or prototyping or manual operation better. In general, I would say enclosed machines, machining centers like this, it's not so accessible for you to reach in there and do stuff with, interact with. Those are more for production use. Open guarded machines like the knee mills we have on the front or the bed mills, those are really good for prototyping, tool room, and one-offs.
Right.
So
You can just stop the machine, just lean in, grab your part, get it out of the way, and
right,
get something else in
right.
there.
And it ties into those machines typically don't have that many tools in the magazine for automatic tool changers, if any.
Yeah.
So they're more limited, but they're designed specifically for the tool room and prototyping. So
Right.
And I would say there's also a factor depending on your business needs. If you're a guy that's doing a lot of single setups or one-offs, low volume work, but you have a lot to do, then your setup time is critical to your money-making process.
Yeah.
If you're making batches of 1,000,000, it doesn't matter if it takes you a day to set up or 2 days to set up because you're going to catch up your efficiency as you produce the large volumes. So depending on the user's approach, also would change what's critical to you. You know, maybe you're a guy just working at home in the shed. You can take a week to program your control.
Yeah.
So you haven't got to go and buy some expensive software that can accelerate the process for you. You don't need to do that.
You don't need to invest in the cam side of things. You can just
So I'd say
fiddle about with it yourself for as long as you need to do
exactly
to get it right.
Yeah, exactly. So there's some factors there, and you know, as you head towards large volume production, there's other factors that begin to come in. You know, is it now worth me putting a robot in place instead of a human?
Yeah.
Can I have a robot pick the part out instead? And other calculations start to come into play.
Andrew's asking, what sort of ballpark figure are you looking at to have a machine, set it up, get the training, and maybe get a half a dozen tools in the magazine?
there's a whole range actually. There's the small routers people get at home. There's DIY style machines. Here at this show, you'll probably see more industrial, um, more production-based machines.
Yeah.
So there's a whole range, but if we're talking about production level or tool room, like traditional tool room, I think it'll start somewhere around 30K and up.
Yeah.
Yeah, it really depends what you're doing. It really depends what you want.
Yeah.
I would say if you go right to the bottom end, you could probably pick up a used machine, fill up the carousel, have it delivered and installed and running. You could have like an old Haas or something like that, maybe for 25 to 35,000 pounds.
Yeah.
You could go even smaller. You could have like a knee mill setup, an older generation.
That's like a turret mill with CNC control
Exactly,
units
yeah.
on it.
And then you might be able to drop another 10,000 from there.
Yeah.
You could go right to the other end of the scale. You're making 1,000,000 iPhones a week, and you can go and spend money on a huge Matsura setup, a multi-pallet machine, and rent yourself a huge factory and spend millions. So there is a vast scale there.
Yeah.
It depends how savvy you are.
Yeah.
I think if you're just talking about a typical component, maybe 200, something like that, 300, and you need a machine tool of this sort of size and enclosed, then you're going to be around £40,000.
Yeah.
Your tooling is going to cost a few thousand, maybe a couple of hundred on coolant and extraction. So maybe 45 would be very, very reasonable price to get set
get
up.
you sort of hit the ground
In
running,
quite a serious way, yeah.
able to just start churning parts out, pretty much.
Yeah,
Okay.
yeah. It's a tricky one with the money because it's on such a huge
Yeah,
scale.
the money
such a
side of
huge
things,
scale.
it's always difficult because what are you making? What's your profit margin? You know, if you're buying the material at £10 and you're machining it for an hour, you need to be charging 50 quid at least for that machine time and the rest of it. So before you know it, that part's 60 quid and you haven't earned anything yet. You've just covered your costs.
Exactly.
You know?
Yes, you have to be savvy. You
gonna
even
have
get
to
some
search
people
for it.
they may be awarded a job by a provider, and in the cost of their contract they can buy the machine.
Yeah.
So you have the scenario as well.
It's not a question right out of the bag to use because it's so dependent. Typically, at what point do customers shift their work to externally source CNC from an internal machining standpoint. So where I work, we're looking at a CNC machine because the manual machining side of things just takes so long that it's going to be way more efficient to have a CNC machine. Plus, we've got the option then of other people can be trained how to load, program, run.
Yeah,
It makes life a lot
it's a
easier
more
that way.
robust process then
Yes.
as well.
An example of, say, batches of 100, tolerances below 50 mics. There's going to be a range of answers that's probably not going to be as accurate as you can make them, but an understanding of that tipping point.
I would say, John, please add to this. In my experience, there's two critical factors. The first one is just the pure figure. What are you spending on subbing this out? Because that figure might approach the cost of a new machine.
Yeah.
And as that happens, you start to see the guys ask questions. Hang on a minute, could we do this ourselves? Yeah. Could we buy a machine? We're spending that same level of money asking someone else to do it. So it seems like that's the initial trigger. And then the second one that comes into play, hand in hand, is waiting for components.
Yeah.
People don't like to wait. It's an unknown. Your customer is waiting for your subcontractor to make the part. If something happens to him, he falls ill, suddenly you can't keep your promise. So that's the second factor that comes in. You can control it and you can save yourself money.
Yeah.
There's other factors. Have you got an operator that can run it? Do I need to hire somebody? And there's other things come into the fold. But I would say the initial driver is probably just seeing that subcon price go up and up and up and up and up.
And potentially the lead time as well.
Yeah.
So if your costs are going up, your lead times are also going up. Then you're going to want to get that back down by saying, well, it's going to cost £50,000 to get those parts made, and it's going to take 3 months. We may as well get our own machine, get one of our staff members trained up to use that machine, and then we've got the machine at the end of it, and it's done all our parts.
Yeah, year one you spend the money, year two you're really starting to save.
Yeah. Yeah.
It's a hard question to answer.
Yeah.
I would suggest, do what you love. If you love to design stuff and not have to worry so much about how to produce it, then try your best to focus and do what you are good at. And then maybe when there's extra time or you have the space and you have power, prepaid power, invest in a used machine to try it out first. Get to know the operation first before really committing into the equipment, new equipment.
Yeah.
So just get a used one and sort of get the whole scope of this operation.
Yeah.
Learn the ropes.
Yeah.
Design to produce, actual produce, inspection, get this whole scope.
Well then that also, as you explore that, it allows you to be more accurate when you go and buy your machine.
You've got the fundamentals down, and it gives you a bit more ammunition then to know which sort of machine to go for.
What works, what doesn't,
Yeah.
You're literally dealing with multiple domains. So you can design to manufacture, but then now you have to learn tooling, setup, operation costs, inspection. And once you get the ropes of all that, knowing more makes the next decision really easy.
Yeah.
So only you'll know whether to also invest in machine, invest in facility to house the machine. It's a business, just like
Yeah, everything comes down to money. If the profit margin's there, it's worth investing. If it's not there, keep subbing it out. So you guys obviously offer machines. Do you offer in-house training as well, or on-site training?
I mean, personally, I've done all three. I've done training in-house, I've done training on site, and we even do remote training. A lot of the times I like to start guys off with a remote session because a full day can be overwhelming sometimes, depending on the guy's prior knowledge. So I like to do a short session online, get them going, learn the basics, move it around, get the spindle moving, let's machine some basics.
Yeah.
And then 2 weeks later, they call me up and they've got a whole load of questions they never would have had. And that's a nice approach.
And if anyone wants to find out about you guys, look at the various machines you do, how's the best way to do that?
Yeah, we've got the website, machmc.co.uk.
Okay.
We've also got the YouTube channel, trying to come up aggressively add content to that. It's MACH Machine Tools on YouTube. You can find any of the Dynafab stuff. I think it's over at Dynafab.
And that's the software behind the machines, yeah?
the control system.
Well, thanks very much for your time. And that's it, guys. Thanks for sticking around if you made it this far. I hope you found everything useful, and I hope you enjoyed the video. Don't forget to rate me down in the comments, and I'll see you in the next one.